Hi static equipment engineers, welcome back. In this video we are going to get inside the ASME Section VIII Division 1 code. Once you open the code, you can able to see two paragraphs which is tagged together. It will be really a painful one to read the code line by line. It is not at all recommended you to read the code line by line. In this video I am going to explain how to read the code, how to read the ASME Section VIII Division 1. In this video we can able to see some classes like UG, UW, UCS and some appendix. In appendix you can able to see two kind of appendix. One is mandatory appendix and another one is non-mandatory appendix. What are all these things? Why it is not stacked like a normal book? It is kind of complicated, right? Why? Actually it has a reason. We will see how to read the code in this video. First of all, what is ASME Section 8 Division 1 and why ASME Section 8 Division 1? In ASME itself we have different kinds of code, right? Apart from ASME also we have EN and we have different kinds of codes, and even in Section 8 we have three different kinds of codes like Section 8 Division 1, 2 and 3. Why especially ASME Section 8 Division 1? It has the basic things like construction rules. It is a industrial standards. Most of the industry use this, and it has a broad application. Construction rules. Actually, the code has this ASME Section 8 Division 1 has the complete package. It is a complete package from starting design to fabrication to testing, everything. It has a complete package. That is one thing. It is industrial standard. It is most widely used pressure vessel code globally. Actually you can able to see that the ASME Section 8 Division 1 we have used it in almost all the countries except some European countries and some other countries, but you can able to see in the whole world will use the ASME Section 8 Division 1 comparing to other codes, and it has very broad application. The application is very wide. We can able to use this ASME Section 8 Division 1 in air tanks, that means air receivers and reactors with agitator, heaters, those kind of vessels, those kind of drums. We can able to use this code. Starting with ASME Section 8 Division 1 is very good option comparing to other codes. Common beginner confusion. As I previously told, it is a map. The code is a map. It is not a novel. When an engineer open the code, they don't know where to start. They don't know how the sections are related. They don't know what is mandatory, what we can able to omit, and what is UG, UW, UCS. As I already told, these three are very important things. In ASME Section 8, not only the UG, UW and UCS classes we have different types of classes like UHX, UCS, UHA and many more. But these three are very important. As I already told, it is a map. It is not a novel. You can't able to read it line by line. You can't able to read it from starting to ending. You have to understand the structure of the code, how the code is structured. You have to understand that. You can able to see here the overall structure of ASME Section 8 Division 1. The very first thing is forward. Actually most of the engineers miss the forward. They don't see the forward at all. The forward has very important thing. We have to read the forward first. After reading the forward, you have to start the code. Speaking about the forward, we need a separate video for that forward. In future I will do that. For subsections I have mentioned here A, B and C, but we have another one subsection which is subsection D, which I have missed here, which is recently added in 2025 edition. And apart from this subsection, we have mandatory appendix and non-mandatory appendix. What are all these kind of things? We will see. We already saw about the subsections. I already told subsections are A, B, C and now D. What are all the important thing in particular subsection? For subsection A, we have UG. For subsection B, we have UW. And in subsection C, we have UCS. And in subsection D, we have different kinds of parts and different kinds of vessels. First, the main important thing is UG. UG is really a important thing. Actually this is heart of the code. If you are well aware on UG, you can able to design a vessel. Without knowing UW and UCS, you can't able to design the vessel. But anyhow you can able to manage once you completely understand the UG. What is UG? UG is a general requirement. The G itself provide general. And what is a U? U I have already told in the previous videos. If you watched my previous videos, you can be able to easily answer that. U means unfired. If the vessel is not fired directly, it will come under ASME Section VIII Division 1. That we denote here as U, and along with that we have G, that is general. And here also you can see that along with U, you can able to see W. W means just welding, and here you can able to see that U, unfired, and along with that CS, carbon steel. Here in the class names we have meaning for that particular classes, and also if you want to design a complete vessel, you have to know the general requirements, you have to know the welding requirements, you have to know the material requirement. And I don't know why I have put this in this slide, it is not required actually. Design, fabrication and material type. Once you know all these three, you can able to design a vessel, but the vessel has some other components also, like lifting lugs, saddles, skirt and mounting brackets, tailing lug. Those kind of parts also will be there. Those are all not covered in most of the codes, they won't cover. Some codes cover the non-pressure components also, but in ASME, in all ASME means ASME section 1, section 2, section 3, in all the ASME, it doesn't cover any non-pressure parts. ASME cover only the pressure parts. Okay, we will see one by one what is UG, what is UW and what is UCS. We will see in detail one by one. First, UG, general requirements. Actually this is the base layer of the code. Actually UG has a broad application. Broad application means you can able to design all kind of vessel, like a carbon steel vessel, non-carbon steel vessel, high alloy vessel, layered vessel, or any other reinforced vessel. Those all kind of vessels you can able to design using the UG, and the UG contains the basic designs, like it contains a formula of thickness, formula of pressure, formula of temperature. Not only formulas, the basic steps how to design a vessel. The basic steps, everything will be available in the UG. It is very mandatory to know UG. If you are not aware about UG, you can't able to design a vessel. So UG is very much important. And next thing is UW. When you have subsection A, we have only one class. Not only one class, we have only one tag, which is called UG. We have UG 1, 2, 3, 4, 5, 6 until 3-digit number you have in UG. But in subsection B, we are not only having the UW, we are having UF, UB and many more. Why? Section B, subsection B is concentrated on fabrication. Some vessels we can able to fabricate using welding. Some vessels we can able to fabricate using casting. Some vessels we can able to fabricate using brazing. Those kind of things we can able to do. We can able to fabricate. The static equipment field is mostly into UW welding. Some field we use brazing also, but if you are familiar with UW, you can easily understand another classes. So understanding UW is very important thing. In UW, what are the things you can able to witness is joint efficiency, radiography, joint types, and how to weld a vessel, and what are all the welding strength and welding thickness you need to weld in a particular parts. Those kind of things will be provided in UW. When it comes to joint efficiency, we have different kinds of joint efficiency in ASME Section VIII Division 1. For pressure parts, we have joint efficiency from 0.7 to 1, that we will see into detail when we get into the code. For radiography also, there will be different rules according to the pressure vessel. Finally, the joint types. As you know, there will be different kinds of joints. Like if you are doing a butt weld, the butt weld has to be fully penetrated. The welding has done with the welding strips. The welding strips removed, the welding strips not removed, it is not a full penetration welding, it is a fillet welding. Those kind of details will be available in the joint type. Until now we have saw how to design a pressure vessel using UG, how to fabricate a pressure vessel using UW, the subsection A and subsection B, and now it's time for subsection C. The subsection C covers materials. If you are designing a pressure vessel, you need to have a material, right? Can be a high alloy steel, it can be a low alloy steel, anything we can able to manufacture a pressure vessel. For the pressure vessel material, we have subsection C. There we can able to see UCS. For the high alloy steel, you can able to see instead of UCS, you can able to see UHA. That means unfired high alloy. And what are the details you can able to expect in UCS means You can able to see material specified. You can able to see the rules for carbon and low alloy steel. You can able to see the MDMT of the material, how to calculate the MDMT of the material, and you can see some limitations. What are the maximum thickness we can able to go? What are the maximum steel grades we can able to go? And also in UCS, you can able to see how the post welding heat treatment has to be done and how the pre welding heat treatment has to be done. Those kind of details also will be available in UCS. The same thing you can able to experience in high alloy steel also. High alloy steels means stainless steel. Take an example as SS316. SS316 has a high chromium content, high nickel content, high molybdenum content. Those kinds of alloy are combined to make a particular steel that is called as high alloy steel. Finally, we came to the mandatory and non-mandatory appendix. What is this mandatory and what is it non-mandatory? Mandatory appendix, you can able to see, okay, this is mandatory to design a pressure vessel, so we have to use that. And why it is mentioned as non-mandatory? If it is not a mandatory one, why the code is providing such hundreds of pages of formula and definitions? As a static equipment engineers, the non-mandatory appendix and mandatory appendix is very good for us. First thing, mandatory appendix. Take an example as appendix 2. In mandatory appendix 2, you can able to design a flange. Normally, if you are choosing a flange, you have to choose from the ASME B 16.5 or ASME B 16.49. There you can able to choose a flange using pressure rate. But if you want to design your own flange, if the ID is not a standard dia, you have to design your own flange. Where we can able to get those kind of things? You can able to get those kind of formulas and those kind of definitions in mandatory appendix. Now mandatory appendix is clear. When we get into the non-mandatory appendix, actually it is a recommended practice. If you have a dimple jacket, you know dimple jacket, right? Dimple jacket is kind of a normal jacket. To reduce the jacket thickness, go for dimples in the jacket, and we weld the dimples along with the shell. To design that dimple jacket, we have no other rules. We can able to refer other books or other codes, but the code has some specific kind of rules for that. We can able to use that, right? Actually, it is not a mandatory one. You can able to design using different code or different standards or different handbooks also. If you can able to convince the AI that I have used Prague or Dennis Moss this design this jacket, means if they are accepting, it's not at all an issue. Otherwise it will be difficult to convince the AI, means you can able to use this non-mandatory appendix. You can easily able to convince them because it is available in our code itself. Otherwise they will ask, hey, you have already non-mandatory appendix, why are you skipping the code and going to the different kinds of codes and different kinds of handbooks? So if we have a procedure in our code, please use that to convince your AI and convince yourself that you have taken it from the code. How a professionals will navigate the code? Professionals don't read the code line by line. How to read a code is very simple thing. First, we know the problem, right? If you are searching for a code, we know the problem, where the problem is. If I need some clarification in designing a shell thickness, I know the problem. The problem is designing the shell thickness. What I will do? I will go for the section. Which section I can able to get that? Under UG, right? I will go to the UG. Under UG, I will find a specific class. UG 27. For the shell design, you can able to see UG 27. So I will find a specific class. And finally I check in the UG 27. I will check what are all the things I need. Reading line by line is completely waste of time, and you can't able to read the code line by line. Why I am telling is, if you read one line, there will be a blue color thing that is called hyperlink. If you click the hyperlink, it will redirect to some other pages. When you are in the first page, if you click the hyperlink in the first line, it will go to page number 1100 and it will redirect to other page. It is specific. They want the code to be like that. The code really needs some experience to read the code. While starting the code, first you need a problem, find the section where the section is, and find the specific class in the section, and finally what you require, check the particular class. That's simple, right? And this is a final slide. We are going to close the video. Okay, before closing the video, I will give you some tips. Don't memorize the code. Code is not for memorizing. You need to understand the structure first. You need to understand how the code is written, and you need to navigate the code. Navigation of the code means, if you had hard copy, directly go to the index. From index you know where you need to see the classes, and from the page numbers you can able to see the codes, right? But if you have soft copy, open the bookmarks. In almost every PDF applications we have bookmark kind of thing. Open the bookmark. From the bookmark you can see different kind of trees. From the subsection A, you have one set of tree. In subsection B, you have one set of the T, C, D, mandatory appendix, non-mandatory appendix. For each and everything, you can able to see a tree kind of thing in the bookmarks. Navigate using the bookmarks if you have soft copy. If you have hard copy, use the index. And finally, use the engineering logic. Engineering logic means if you are designing a shell, the shell has tolerance, the shell has different kinds of tolerance, and some exemptions will be there, right? So code doesn't provide those kind of things. You need to use your own engineering logic and apply those tolerance or anything in the formula, get the result using that. If the code is blindly giving a value for the thickness, it is not the right one. That's it, very simple. I hope hereafter you can able to learn the code very easily. You have to turn the pages very easily. Don't stay in the first page, turn the pages. Most of the time when we start learning the code, we will stuck in the first page. Yeah, it will happen, but turn the pages. Okay, bye.